Sorry. Yep. So the way to think about these exercises, I'm not going to ask you directly if there's a change specifically in the base, right? Or in the money multiplier. But you must be able to know what's the final effect on the money supply, right? So if currency increases, so if I buy government bonds, then there's more. If I buy, the central bank buys government bonds, then that means that they're increasing currency, right? And that would increase the money supply. If they increase the interest on reserves, then banks are going to hold more reserves. There's less high power money, right? There's less multiplier effect. That's going to reduce the money multiplier, which reduces the money supply. If I reduce the lending rate, then banks loan less to other agents, and that's going to. I'm sorry. If they reduce the lending rate, banks borrow more to make more loans, and that increases the money supply. If the currency to deposit ratio increases, then that means that I have more money. I have money in my I have money in my mattress, right? That's what they said. It was maybe sometimes safer just hold money in your mattress instead of putting in the bank. So that way I'm also not letting the propagation mechanism to work, right? So that would also reduce the money supply. Yeah.
So why is money problem? Because the currency deposit ratio is also in the denominator, not only the denominator.
Yeah, but you have 1 on top, so.
Why is that money problem? Currency deposit ratio.
So since you have a 1 on top and the reserve to deposit ratio is less than 1, and increasing the currency to reserve ratio is going to reduce the money supply. Right? Yeah? So the money multiplier is always greater than 1, right? It cannot be less than 1. So if the currency to reserve, the currency to deposit ratio increases, then that lowers the money multiplier, right? So in this case, what happens to the reserve to deposit ratio? In the case that people increase the currency to deposit ratio. Nothing. Why? Because that's the decision either from the central bank or banks. That hasn't changed, right? Finally, in celebration of Whacking Day, Major Queen Bee flies on a helicopter of a Springfield, dropping $1 million over the city. Then it would be the same as the first case, right? It's just an increase in currency, which wouldn't affect the money multiplier, only increases the monetary base, and the money supply increases, right? Make sense? So, any questions about the money supply? And if you feel like it was a little bit confusing, maybe it's the first time that you heard about all these terms, then the best way is and the book gives a lot of examples about it. So you can start reading the book, and that way I can assure you that it's going to be perfectly clear. So it's not a hard topic, right? So that's one chapter. So as you see, so it wasn't long, right? So now we're going to go to the other chapter, which is the money demand, right? So the good thing about our money supply model is that the money supply then it's always going to be controlled by the central bank. And it's always going to be perfectly inelastic, right? So it's always going to be fixed, right? The amount of money that there's in the economy is going to be always fixed. So we're always going to have a perfectly inelastic supply curve for the money supply, right? So now we're going to talk about the quantity theory, the money demand, right? In particular, we're going to talk about the money demand in the long run, right? How can what determines my money demand in the long run? So, the way to study my preference for holding money in the long run, right, in the classical view, is called the quantity theory of money. The quantity theory of money was developed by David Hume, and it remains the leading explanation for how money affects the economy in the long run. It is based on the insight that people hold money to buy goods and services, right? So if you take another course of monetary policy, you're going to see that introduces money into a real economy model. There are three ways that you can do it. One way is just, two. The first one is just to put money in the utility function. So you hold money because you like money, right? It's just a commodity, so it would enter your utility function. And so, I mean, does it make sense? Do you hold money because you like money? But maybe. What's the main purpose for holding money?
Get rid of the risk.
Okay, so now you're comparing money with other assets, right? What's the main purpose for having money in your wallet?
Make transactions.
Very good, to make transactions, right? So, I mean, right now, does anyone have like more than $100 in their pocket? No, right? Why not? Now we have debit cards, credit cards, we have all these financial instruments that are helping us, right? So that's why it becomes harder to think about money in terms of, we use it for transactions, right? Yeah? So, equation number 2 is known as the exchange equation. Why? M, we said that it was the money supply, right? Sorry, M would be going to be the money demand, right? So the amount of money in the economy times V, which is the velocity of money, is going to be equal to P times Y. Y was, sorry? Output, very good. Production. And P is the price level, right? So if Y is real income, P times Y is nominal income, right? Or, in this case, nominal production, right? The total dollar value of our production, so nominal GDP. So nominal GDP has to be equal to the amount of money there is in the economy times the velocity of money. So first, to understand this formula, we need to know what is the velocity of money, right? So the velocity of money is a measure of the rate at which money circulates in the economy. It tells us the number of times a dollar bill changes hands in a given period of time. Right? So it tells me, I have $1 bill. What is the rate at which it takes the dollar bill to go all the way from the economy to come back to me? Right? Make sense? So for example, if I put more money in the economy, if I drop $100 in the economy, $1 million in the economy, would the velocity of money go up or down? Down, very good. Why? Because now there are more bills. So that means that the same bill is going to take longer to go all the way through the economy to come back to me, right? Very good. So if I multiply the amount of money, that the amount of bills, currency that is in the economy, and I multiply it by the velocity, what would I get? I would get the number of transactions in the economy, right? And the number of transactions in the economy has to be equal to my production, right? Does it make sense? Remember, everything's in real. There's no financial assets here, right? So we're not talking about bonds and stocks or debt, right? We're just talking about goods and services. So if I calculate what's the total number of transactions in the economy, that should be equal to how much I produce in the economy, right? Including services. So that's what equation number 2 is telling me. In equilibrium, right? The number of transactions, we would be the left side, has to be equal to the amount of money times the velocity of money. Yeah? So, even though we have money in our model, once again, we don't care about nominal variables, right? In the end, what we care about is real variables. So that means I don't care about the actual money. So money doesn't enter in my utility function as just because I like looking at it, right? I have money because I use it for transactions, right? So what I'm interested in is in the purchasing power of that bill, right? So that's exactly real balances. So real balances are the measure of the purchasing power of my stock of money. Right? So my demand of money is not going to be given just by how many bills I want, right? But exactly how much purchasing power I want. So if you see, it's in real terms, not in nominal terms. Right? I don't have the $100 bill because I like the $100 bill. I want that $100 bill because it allows me to purchase an amount equivalent to 100, right? So what I'm demanding is not actually bills, but purchasing power. And that demand of purchasing power is called real balances. Yeah? Make sense? So my money demand function is the equation that shows the determinants of the quantity of real money balances people wish to hold, right? So how did we start? We said people want money because that lets them make transactions, right? One way I can measure transactions is using the exchange equation. The exchange equation, which tells me that money times the velocity of money equals the number of transactions in the economy, right? Which in the end is equal to the nominal GDP. Then I say, when people don't actually demand money, they demand purchasing power of that money, right? That's called the real balances. So now we're going to specify a demand for real balances. The easiest way would be, well, what I want to do is I demand as much money as a fraction of my, so in that case, Y would be of my production. That doesn't make sense, right? Of my, how do you decide how much money to take out from your bank account? Sorry? So it depends on how much you're spending, right? Very good. But it also depends on what fraction. So what fraction of your income do you want to hold in money, and what fraction of your income do you want to leave in the bank, right? Make sense? So the easiest money demand, the easiest money demand is just to say, well, I want to hold in money a certain fraction of my income. So in that case, Y is income. Remember, income always equals spending, always equal production, right? So in the first equation, MV equals P times Y. Y was production. But here we're looking at it from a point of view of consumers. So in that case, my demand for real balances equals a fraction of my income. Right? So this is where you have to be a little bit careful, and it generates a little bit, sometimes generates a lot of confusion. This is my money supply, right? My money supply is in terms of dollars, right? This is a nominal variable. So in order to have the real variable, I have to divide it by P, right? That would be my real money supply, right? The real money demand, it's already the real money demand. It's not that I have some nominal amount and then I have to divide it by prices. My money demand function, what I say M over P, is the money demand function, right? It's not MD over P. Because then when you make them equal to each other, the cancel each other out, and then, oh, that's it. The name of the variable is exactly m. I'm not transforming it into a real variable. It's already a real variable. Make sense? That's why I'm putting difference here. Is that here I'm transforming it into a real variable by dividing by p, and here it's already a real variable. It's a real money demand. Yeah? Make sense? Why is the difference? The difference is because if the prices go up, that's going to affect my real money supply, right? But it's not going to affect my real money demand. My real money demand is already a variable. It's only the variables that affect the money demand are going to change it, right? You're going to see right now with the complete model. But I want to emphasize a lot. It's not that it's the money demand divided by P. I'm not transforming the money demand into a real money demand. It's already a function in real terms, right? But you can see that there. It's just K times Y. There's no P dividing it, right? Yeah? Just that you be careful that whenever we say, okay, prices go up, that's going to reduce my money demand. No. In this case, the money demand only depends on income. If my income is higher, then my real money demand is higher. Right? Yeah? So, exercise 241. Edna Krabappel, I didn't know that she died. They killed her. Do you know that? No? Edna Krabappel made the following two statements to her 4th grade class. The velocity of money is directly related to the proportion of how much people want to hold for every dollar of income. Is that true or false? The velocity of money is directly related to the proportion of how much people want to hold for every dollar of income. True or false? False? It would be, it's false, but it's not directly related, it's inversely related. How can I show it? So the velocity of money is directly related to the proportion of how much people want to hold for every dollar of income. Let's see. I have that my money demand equation is K times Y, right? So this is the proportion of money that their income that people want to hold as money, right? And I have my exchange equation, which is M. This is the supply. M is P. It's P times Y, right? I'm just going to read. Oh, I'm writing too small. I'm sorry. M over P. D is K times Y. Money supply times P equals P times Y. I'm just going to rewrite that equation as MS over P equals Y over V. What do you think is the next step? I'm really close, right? What would be the next step? What must be true in equilibrium? We're really close. We have the real money demand, and here we have the, what is this? The real money supply, yeah?
Can we substitute the top equation like K over and put that equation where Y is?
Yeah, but, so that's what we're going to do. But why do we do that? It's because in equilibrium, money demand, very good. Money demand equals money supply, right? So in equilibrium, my real money supply has to be equal to my real money demand. So that means that Y over V equals k times y. The y's cancel with each other, and I have that 1 over b equals k, right? So that means that the amount of the proportion of money that people want to hold as real balances is inversely related to the velocity of money. Yeah? Think about it for a second. You can. So who can answer that question? She's saying, I cannot cancel them because this one is income and this one is production. Yeah?
Don't we have like a national accounts identity which shows that production is income?
Very good. Production always equals income. We showed that in second class, right? Yeah? Makes sense? Production always equals income. Spending always equals income? No? Only? Okay, very good, but there's still a little bit more. Spending only equals income. Spending only, yeah? Yeah, that's what she said, but a little bit more. I need more.
Interest rates.
Very good. At the equilibrium interest rate for the loan all funds market. But production always equals income. We showed that, right? Very good. Finally, the quantity theory of money states that the central bank has ultimate control over the rate of inflation in the long run. Is that true or false? So, what I said in the beginning, I said that I always emphasize that the central bank and the government are separated, right? Why? And we're going to see that, like the last class, I'm going to talk a lot about the bank's credibility, and I'm here to convince you to work for the central bank. The bank's credibility, how autonomy is very important. But the reason is, so for example, in Latin America, what used to happen is that the central bank and the government were really close together, right? So, for example, in Mexico, there was in the 70s, that's when they discovered that Mexico had a lot of oil, right? So what happened? Well, a lot of people wanted to invest in Mexico, they started investing in Mexico, and what the government did was take that money, and instead of using it appropriately, they just started to buy more things, right? Start buying, spending, and the problem is that, okay, yeah, I'm going to promise you that I'm going to buy a certain amount of barrels of oil, right? So the government used that as an excuse to start increasing their spending, but they haven't actually paid that amount, right? So they started to issue debt. Who would buy the government bonds? Well, the central bank, right? And then what happened? The price of oil crashed. So the government debt went up, and the governments just started to use the central bank as its little bank, started printing money like crazy, and then that's when we have the periods of. What do you think was the result? Of course, we had a crisis. Yeah. Very good. We had periods of high inflation, of hyperinflation, right? 100% of inflation. Why? Because in the long run, if you print money, the only thing that you're going to generate is inflation. How does that work? Let's suppose that, okay, I give you $1 million. What would you do with that $1 million?
Spend it.
Very good. You're going to spend it, right? But my production is fixed, right? In real terms, my production is fixed. So once suppliers see that you go and start buying a lot of things, well, I cannot control the supply. So that means that the only thing that I'm going to do is I'm going to increase my prices, right? Yeah? So I increase my prices, and then that way I go back to equilibrium. But the problem is that I'm not changing anything in the economy, right? I'm just generating inflation. Make sense? So now we're going to show that using this model, right? That in the long run, money has no impact in the economy, right? So whenever they say, the central bank is evil, or the Federal Reserve increased interest rates, so they should increase. In the end, in the long run, has no effect in the economy, right? We're going to see that in the short run. Of course, the stabilization policy is very important, right? But in the long run, no. So this is related with our first Nobel Prize winner, with Friedman, right? He said that part of the reasons why the Great Depression was so bad, it was because of interventions by the central bank, right? So, I say it's true. The quantitative theory of money states that the central bank has ultimate control over the rate of inflation in the long run, right? So, I start with my exchange equation, and I work in terms of inflation. So since I want it in terms of inflation, inflation, remember, is just the increase in prices, right? So how do I change this formula to so that it includes inflation? Very good. So I noticed that some of you had a lot of trouble with the growth questions, but whenever we talk about growth, you just have to use the arithmetic trick in the first note. The arithmetic trick was saying that if two variables are multiplying, then the growth rates are adding, right? You can show that just using the chain rule. So if you do it, it'll take you long because you have to take the derivative of two variables and then calculate the chain. But you can just use directly the trick. Whenever two variables are multiplying, the growth rate is just the sum of the growth rates, and the same thing on the right hand side. Now, that's the first thing to succeed in the midterm. The second thing is going to be what determines each and every of the variables, right? So there were questions about how are we supposed to know what happens to employment? Well, the thing is that employment doesn't change because we said that it was fixed, right? So if I didn't tell you in any part of the course, well, this variable affects employment, that means that employment remains fixed, right? Do you agree? So the way to understand the exercises is just determine, okay, which variables affect which variables, right? Consumption is completely determined by consumption is determined by, and then you can relate it to your life. What does your consumption depend on? Your income, not only your income, but your disposable income. What does investment depend on? The interest rate. What does net exports depend on? The real exchange rate, right? Very good. So, when I introduced the velocity of money, I said that the velocity of money was just a measure, right, of how money moved throughout the economy, right? That means that the velocity of money is a constant, right? So since the velocity of money is a constant, and we actually showed it, right? We showed that the velocity of money was always equal to 1 over k, where k was the proportion of income that people would hold as real balances. Remember, real balances is just real money, right? So since v equals 1 over k, so it's a constant, that means that the percentage change in v is 0, right? The growth rate of the velocity of money is 0. Makes sense, right? It's just a variable. What about y? What is the percentage change in y? In our model, how is our economy growing? What is the growth rate of the economy? Okay, yeah, so you're saying, so, very good. So you're saying y equals a k to the alpha, L1 alpha, right? So the growth rate of output is just the growth rate of technology plus alpha, the growth rate of capital, plus 1 minus alpha, the growth rate of labor, right? And all of these are exogenous variables, right? Yeah? So the change in y is determined by the factors of production and of course technology, right? I'm just going to take a little bit. One second. So in the end what I have is that the percentage change in M equals the percentage change in P plus a constant, right? If I increase M, that's not going to affect the percentage change in Y, the growth rate of production, right? Because the growth rate of production is determined by something outside of my model right now. It's determined by the growth rate of capital, labor, and technology, right? That is the classical view of the money market. An increase in the growth rate of the money supply generates inflation, 1 to 1. Make sense? So now I'm starting to introduce a new term that I hadn't used before. Classical view of the money market. Whenever we talk about long-run variables and the impact of long-run variables, that's called the classical models. So we have seen right now, all of that, it's a classical model. When we start looking at the short run, that's called Keynesian models. So whenever they ask you about, so what's the classical view of the money market? You'd say, the classical view of the money market is that money generates inflation in the long run. That's it, right? Make sense? Yes or no? Yeah? Very good. So to conclude this chapter, so we had our demand for real balances was quite simple, right? It was only dependent on how much money you wanted to hold, depending on your income, right? But so when I asked the first time, someone told me, well, it depends on maybe you want to invest, right? Maybe you want to hold government bonds, right? So it depends on how you want to distribute your income in different assets, right? And now, in order to talk about those assets, we need to introduce the nominal interest rate, right? Because now, what is the cost of holding money? What's the opportunity cost of holding money? It's going to be the nominal interest rate, right? Why? Nominal interest rate is a good approximation of how much the bank pays you for having your deposits with them, right? So that means that if I take one money from my bank account and I hold it as a bill in my pocket, then what I'm losing is exactly the nominal interest rate, not the real interest rate, right? Real interest rate is related for investment. The nominal interest rate is going to be related with money. Yeah? So the nominal interest rate is not going to affect directly real variables, right? The one that's going to affect real variables is the real interest rate. So, definition, the nominal interest rate is just the interest rate that commercial banks pay. And the way in which we can relate the nominal interest rate and the real interest rate is by using the Fisher equation. What does the Fisher equation tell me? The Fisher equation is a relationship between the nominal interest rate, the real interest rate, and inflation. Does that equation make sense? So, how did I convert nominal variables into real variables? I would take the nominal variable and divide it by price, right? And then if I had a growth rate of that real variable, I would have that the growth rate of the real variable equals the growth rate of the nominal variable minus inflation, right? So you see where I'm getting at? The nominal interest rate, which is a percentage change, equals the real interest rate, which is a percentage change plus inflation. So it's also determined by using our trick on growth rates, right? It's also an approximation, but the Fisher effect is very important. So, show that a 1% increase in the money supply increases the nominal interest rate by 1%. What determines R? What determines the real interest rate? Yeah? Close, very good. One is investment demand, but you also need very good savings. So it's R is determined by the equilibrium in the loanable funds market. So Y is determined by the factors of production. R is determined by the equilibrium in the loanable funds market. The money supply is determined by the central bank, right? So, how can I show that a 1 increase in the money supply increases the nominal interest rate by 1%? How do I relate money and inflation? With which I just showed, right? I said the percentage change in M equals the percentage change in P, right? Plus a constant. Remember? Yes or no? So, if there's an increase in 1% in M, then there's going to be an increase in 1% in P, so I'm going to have 1% more of inflation. And then using the Fisher equation, I have I equals R plus pi. R is determined by the equilibrium in the loanable funds market. So an increase of 1% in P is going to increase in 1% the nominal interest rate. So our link between the money supply and the nominal interest rate is going to be through the Fisher equation, always. Monetary policy is going to have its effect on the nominal interest rate through the Fisher equation and the quantity theory of money. The quantity theory of money tells me that an increase in the money supply increases inflation, and the Fisher equation tells me that an increase in inflation increases the nominal interest rate. Right? Yeah? Now, inflation, it tells me how much prices are growing, right? So I can know, today I want to make an investment, right? I need to have all the necessary information. So would I care about my real return investment or my nominal return investment? Yeah, so would I care about my real return investment or my nominal?
What's the question?
So if I'm making an investment, right? Would I care about my real return on investment or my nominal return on investment? Real, right? Can I actually know the real return on investment? No, right? Sorry? No, right? What I can know is the nominal return on investment right now. So if I go to a bank and I say, okay, so I want to invest in these bonds, they tell me what the nominal interest rate that they're going to pay me is going to be, right? The only way that I can determine my real return on investment would be using the Fisher effect, right? The Fisher equation. However, I don't know what inflation is going to be like, right? So if I want to make, for example, I want to buy bonds, 30-year bonds, then they, okay, I'm going to give you this interest rate, 2%. The way that I can determine what's going to be my real return on that investment is by using my expectations of inflation. What are going to be my inflation expectations, right? I cannot know how. I cannot know for sure what inflation is going to be, but I can make some assumptions on what I expect inflation to be, right? And that's called an inflation expectation. So the last part of the course, we're going to talk about exactly how to model them, right? But for now, we're just going to assume that they're completely exogenously determined, right? They're only going to be affected by future policy of the central bank, right? So, for example, if the central bank today says, I'm going to increase the money supply, then what's going to happen to my inflation expectations? They go up, right?
Well, doesn't the central bank give an inflation expectation target?
So we're going. They have a target, so that's different. So it has to do with the rules of monetary policy, right? Whether it's discretion or commitment. Sorry, the Federal Reserve right now, they don't specify. They recommend a specific target for inflation, right? But it's not strictly inflation targeting. But that, I mean, even if the central bank says that my target is 2%, would that mean that all my inflation expectations are 2%? No, right? It depends on how the economy is going. Right now, inflation expectations are really low. They're around 0%, right? We're going to talk about that more a little bit more. But right now, we're going to assume that with what we have, if the central bank announces that they're going to increase the money supply in the future, that would increase my inflation expectations, right? Because I know that by the classical model, an increase in the money supply increases inflation. So if they say in the future I'm going to increase the money supply, that would increase my inflation, my expectations of inflation, right? Very good. So, in order to differentiate between the interest rate that I can actually observe and the one that I cannot observe, I define the ex ante and ex post real interest rate. So the real interest rate that the borrower and lender expect when a loan is made is called the ex ante real interest rate, and is determined by my expectations on inflation, right? And the interest rate that is actually realized is the ex post interest rate. So the ex post interest rate would be the formula number 4, right? Once I observe inflation, then I can know what my return is, right? What my actual return was in my investment. Make sense? So the ex ante includes expectations of inflation. The ex post includes the actual inflation, right? How is that related to my model? Well, because now my money demand is also going to include the nominal interest rate. Which interest rate? The ex ante or the ex post? Ex ante. Why? Because when I decide how much real balances I want to hold right now, it depends on what the nominal interest rate is right now, right? Yeah? And that nominal interest rate is determined by my inflation expectations. I don't know what inflation is going to be tomorrow, right? So I have to form an expectation of what that inflation is going to be tomorrow. So the opportunity cost of holding money is the nominal interest rate, what we said. With this insight and using the Fisher equation, we can write a more general money demand function. So my money demand function, I'm just going to call it L. Why L? Liquidity, right? So it's my preferences for liquidity. L, which is going to be a function of the nominal interest rate because it's the opportunity cost of holding money, and my income, right? And using the Fisher equation, the ex ante Fisher equation, because I cannot know what inflation is going to be tomorrow, I just substitute it and I have that my money demand is going to depend on the real interest rate, expectations of inflation, and my income. Right? So, to finish, so you see that's why I tell you that it's better if you read the chapter first and then you come to class, because what I do is I spend at least like more than half the class talking about the definitions and trying to explain all the concepts, and the last part I do the exercises, right? So if you read the book before, then you understand better what I'm explaining, and then in the end you can apply better the exercises, right? If not, it's a lot of information for you to absorb in 2 hours, right? So whenever you're studying, and you really need to start studying now, because so on Monday we're going to start the solo growth model, right? So it would be my recommendation that you finish the problem set, even though it's due on Wednesday. My recommendation would be for you to finish the problem set before Monday, so that you use the next week to study solo growth model. Why? It's a new type of model. You've never seen something like this before, so it's not demand and supply. It's actually a model that shows me how capital evolves across time, so it needs a little bit more practice, a little bit more reading. So it's better if you have more time for it to study, right? Okay. So exercise 2.3. Major Quimby announces that in the next month he will begin to buy an exorbitant amount of government bonds if he is not reelected as major. Using the money market model, show the impact of Quimby's announcement today on the economy of Springfield. Make sure to draw a graph and explain the transmission mechanism. So let's forget about Springfield for a second, and let's just suppose that the more direct exercise would be, what happens if the central bank announces that it will increase the money supply in the future? What's the impact today? Okay? So finally I have my graph of the money market. My graph of the money market is going to include my real money supply and my demand for real balances, right? And what is the opportunity cost? What's the price of holding money? We said that the price of holding money is given by the nominal interest rate. Very good. If you put R here, that's wrong. That's wrong. That's wrong. R is determined by savings and investment in loanable funds market. I. Very good. So what happens if the central bank announces that they're going to increase the money supply in the future? Very good. So, in the future, the increase in the money supply is going to increase inflation, right? Yeah? By the quantity theory of money, right? QTM, quantity theory of money. So that means that today, my inflation expectations increase, right? Yeah? Then, by the Fisher then by the Fisher equation, what has to happen to the money, to the, what happens to the nominal interest rate? It's higher, right? Why? So we have, this is my nominal interest rate, right? R is determined by the low nominal funds market, but I have higher inflation expectations, so the nominal interest rate has to be higher, right? And the Fisher equation implies that the nominal interest rate is higher. Why? And this is very important because R is determined by the low nominal funds market. Good thing that I'm taping it so that then I can just play myself back again and say, I told you in class this happened, right? Right? Okay. So I have a higher nominal interest rate, right? I'm moving along my demand curve. What needs to happen now? Is there an equilibrium? Can we just leave it like that? No. Something else needs to happen. We need to, okay, so everyone's telling me, move the money supply to this side. Okay, very good. But the thing is that MS is constant. MS is determined by the central bank, right? And they're not changing it today. They're saying, in 3 months, I'm going to change the money supply. So the money supply is not changing, and I need to move the real money supply to the left. That means that prices have to go up, right? So, since MS is fixed, then prices have to go up today so that the real money supply shifts down or to the left, right? Decrease. And then I'm back in the equilibrium, right?